No se ve nadie que venga, ¿verdad? Ok, voy a empezar entonces. Good morning, everyone. We are going to start the second keynote of this conference. The keynote will be delivered by Ulises Xolocotzin. He is a researcher in a mathematics education department in CINVESTAV, which is a prestigious research center in the north part of the city. I like Ulises. I hope you like me also. Uh, yeah, since we met, we kind of made click. Even though he has something interesting about Ulises is that he has this psychologist background, and I find this very interesting. In that kind of area, replication studies are more common, I think. So I like that from Ulises, and I learn from that. We have one student together. We publish a replication study with this student. So that's the topic of today's keynote, replication studies. Thank you very much, Ulises, for coming. The microphone is yours.
Buenos días a todos. Good morning, everyone. Thanks for being here. I understand that it's already Thursday, so you might be tired. So I appreciate very much that you woke up early and for attending this talk. Well, as Mario said, we've been working together. I also like Mario, so it's mutual. And I'm very grateful for with the organizing committee of this conference for inviting me to do this talk. I've been working on this, and it's been very challenging because I want to talk about some things that we can learn from our neighbor field of psychology, but trying to translate that into something that can be helpful for our community. It's been complicated. I hope I have achieved that. And so also, I'm very sorry for being late. I live very far from here, and it's very unpredictable in the city. So I hope it's not that late. So please let me start. My talk is called Replication-Based Learning in Mathematics Education. And it's composed by 3 different sections. The first one is, of course, the introduction. These are the 2 key messages I want to give you today. One is that, as we've been talking about throughout these days, in order to improve the reliability of research in our community in mathematics education, we need to make important individual and cultural shifts. And one of those shifts is the adoption of replication studies in a more widespread manner, trying to make it a more generalized practice than it is nowadays. The second is that one of such shifts is the introduction of replication studies in the apprenticeship process of our mathematics education students. I mean, future researchers in mathematics education. This is, I think, one of the most important parts of this replication, new culture of replication that we want to begin with this conference, for example. So let me start with this. As Mario said, I'm originally a psychologist. I'm originally a psychologist, so I know a bit about the story of how replication studies began to become a common part of psychological research practices nowadays. It all started like about maybe 15 years ago. I don't know if you remember. Maybe not, of course, because this was a very huge thing in psychology. There was this. I'm going to give you 2 examples. One is this the case of this researcher from Tilburg University, where he's been. It was a very big scandal because he had a lab. He was a very well-known researcher in social psychology. He earned lots of awards. He had a massive publishing record in very prestigious journals. And it turns out that around 2011, some members of his lab started to send letters to different journals saying, oh, well, this is some suspicious practices going on in this laboratory. Please take a note on that. And it all started an investigation within Tilburg University. And at the beginning, this researcher, I mean, I'm not saying his name, but I mean, it's very easy to find. And after this investigation, well, at the beginning, of course, the researcher denied all the accusations. But then after a while, he had to accept that. And then it all started a process of finding which of his studies were I don't want to say real, but based on actual data, and which other ones were based on fabricated data, which is what he has been accused of. So here's an example of the headlines during those days. In the left, there is the this note from the New York Times where that is not New York Times, I don't remember what. See, I think it's New York Times, where this person who at the time was the president of the International Psychological Association was talking about the case, just reflecting on it. And this is the retraction published in the Journal of Personality and Social Psychology, which is the important outlet of social psychology. In this occasion, this is a retraction of about 8 different papers, right? So this is one example of course, this created a whole crisis of credibility in the psychological, in the discipline of psychology. It was a huge scandal. So, and was one of the events that precipitated this worry about, okay, how can we tell the world and people and other scientists that we are a respectable discipline, right? So this was one case. This was the most scandalous case. There were others, more perhaps more constructive, where it started this worry. I mean, this process of thinking about which of our findings in psychology that we take as a given are actually based on actual scientific practice and which ones are not. And of course, there were many that were that came under the scrutiny of other researchers. But I want to give you this example. This finding from Daryl Byrne was very famous at the time when it was published. That was again like 2011, 2012, I don't remember. And it's about something called the psi phenomenon, which is a series of experiments where the authors, I mean the members of this laboratory, tries to prove that under certain conditions, people can have affective reactions about some things that have not happened yet. So as is sort of, you can feel something that about the future. I mean, of course, everyone knows people who claims to do that, like, oh, I can feel that we want to have an earthquake like next week, and I had a dream about that, and I have this feeling, so on. It's called precognition, right? It sounds a bit like magic or science fiction or something. But the thing is that in this occasion, in this particular paper, there are like 5 different experiments trying to prove that that is actually something real, that happens to some people. And well, at that time, the data, the experiments prove that. So, okay, it's been published again. in the Journal of Personality and Social Psychology. But then, during this whole crisis of credibility and worry about what can we do to make this sort of finding, which is of course very controversial, say, okay, it's an actual thing, it's not a fabrication. So there was this other paper some years later where the authors requested the original author to give them access to his data and his materials, right? And then with that, they replicated, right? And made analysis including the original data plus other different data. And they found that the actual evidence for Berne's claims that some people can feel about the future is actually not there, right? So same data analyzed differently says something different. So the take-home message of this sort of study is that first, there are many different practices, or there used to be, or there are yet, some practices that are actually detrimental to the production of scientific knowledge. For example, in the use of statistical analysis in ways that can be described as, like very flexible, for example, right? So trying to find a significant result and then just moving your numbers in different way, just aggregating data in different ways to see, okay, there's something, or trying just to, like some people say, just try to massage the data, see what you can find, right? And this kind of study sort of shed a light on the importance of having common practices for analyzing data, and also for saying, okay, I'm gonna. It all started the interest for open science and things like pre-registration, which is when you have an idea, you write up your protocol and then send it to the journal before actually running the experiment, and then you ask the journal to analyze that and say, okay, check my protocol, see whether my stimuli is correct, whether this is the analysis I'm going to make, this is the size of my sample. And then once the journal approves that, then you go on and do it, right? Before running it and then just reporting it, which is what most social science disciplines do. But the risk on doing that is this kind of thing, that when you have the result, then you analyze onto something that you have already done. And because there's no actual transparency of what you were going to do, well, you can just report and write it up as if you were thinking ahead of that, which is not true, right? So anyway, those are two examples of the kind of situation that started this whole replication crisis in psychology about 15 years ago. So after that, there were lots of different initiatives. So instead of trying to hiding it or to deny that that sort of practices were happening, the psychology community said, okay, we need to do something. And some persons organized themselves and started projects like this one. This one is I would say the main one is the Open Science Collaboration, where there were about 270 different collaborators from different universities around the world saying, okay, we need to select a number of findings, a number of studies that we believe are important and say whether they can be replicated. Because at that time, when you, as it happens in every other discipline, once something is published, you take for granted that that's something that has been under the scrutiny of other scholars, and then it's actual knowledge, right? And then you use it, and then you construct new knowledge on the basis of that. So they said, okay, we need to select how much of our knowledge is actually something, well, valid, right? Not unreal. It's not that the results are not real, just like are strong enough to survive a replication. So in this particular case, in this project, the participants selected a number of different, I think about 100, sorry, I forgot the number. They select about 100 different studies, and they said, okay, we're going to replicate that in different laboratories, different universities. Yeah, 100 experimental and correlational studies that were published in on the most important journals during 2008. So they gave the participants the opportunity to say, okay, out of these journals, we're going to take a sample, and then every laboratory is going to select one to replicate. So when it was possible, they asked their first author or any author to share their materials and their original data, and then try to replicate that with the same materials to see whether you get the same data, right? Or if not, why not? So they did that. It was a very important project. Thanks. Gracias. Right. Yeah. So this is a graph. Let me explain a little bit about how this works. Basically, what they found is that out of the 100 studies that they replicated, about half of them did not replicate the significant result. So in this line this line shows how when the point is exactly on the line, that means that the replication and the original study produce the same results. Above the line, there is a significant result that was not found in the original paper. But below the line and up to here, there's the papers whose results were not replicated. So as you can see, most of them were not. So of course that increased the worry, right? So because now instead of having a scandal or some anecdotal thing, we have a systematic review of how replicable is knowledge in psychology. And then you found that, well, almost half of it is not. So that was worrisome. And it all started different initiatives. For example, this one, right? Of course, across conferences, everyone was talking about that. It was a really weird time. And you would say, okay, our discipline has no credibility now, because then it just, this sort of lack of reliability of results and the lack of replicability of results transcended the academic area, and it went into the newspaper. So people interested in science or academia were saying, well, in psychology, you are really not doing actual science, are you? And then, of course, that's heavy. That's a heavy burden to carry. So we started with this. Well, things, for example, lots of papers, lots of discussions, starting, for example, this one by Munafok, which is a manifesto for reproducible science. Of course, this comes after different discussions and different workshops and different talks in conference and so on. So what I'm trying to say is that this sort of manifesto required a lot of analysis and say, okay, well, about lots of analysis to find out what were we supposed to do. So, for example, this manifesto for reproducible science, the emphasis is exactly in that, and saying, okay, how can we make our practices more reliable in a way that we can reproduce the results that we are claiming to be true, that an actual finding can be useful, otherwise it's not. So here there are different points, that different proposals of this manifesto. For example, most of them we've been discussed about. For example, just avoiding publication biases. For example, when journals just prefer, or editors used to prefer, original studies instead of replication. Cognitive biases, for example. One, which is the one I'm going to focus today, is improving methodological training. That is introducing studies to practices, not only the technical part of it, but also this sort of ethos about being transparent and report everything that you do. And saying, okay, I did this, and this is how I did it. Okay, and other things that I think are relevant for our discipline, and not all of them, of course, but for example, collaboration and team science is a very important one. Pre-registration studies, improving the quality of reporting, protecting against conflicts of interest, of course, encouraging transparency, diversifying peer review, and also one which is very important, which is rewarding open and reproducible practices, right? I'm going to come back to some of these things later. But this is, for example, something that is more on the positive side, which is, okay, how this replication crisis forced us to make some, or think about making structural or individual changes for the benefit of our community. And I don't know if you can see this. It's very small, right? But for example, there are 3 areas of change: the structural change, procedural change, and community change. In the structural change, we have things like making open science initiatives, convincing institutions to give different incentives for researchers to do replications, right? And one of them, which is the one I want to talk about today, is including open science in the curriculum. If there's something there that relates directly to replication, it's the practices of open science. If you want to replicate something, you need to have information on how to replicate it. Otherwise, it's very difficult. And when we see one published study and we see the method and there's something that you don't know how to replicate, then that's impossible to replicate. It's not going to be. And to change that, you need to teach your new research, your students who are going to be the new maths education researchers, how to conduct open science. It's not like it's not something. It's not only technical. It requires a way of thinking, right? So other changes that were proposed, of course, there were community changes, and one important part that I would like to stress a lot is making big collaborations, just like in cross-institutional collaborations. That would make more transparency, that makes more power, and gives you also the opportunity to make a change, because then the practice of, for example, doing replication together across 2 or 3 different groups gives a different message to our students. You are teaching them to collaborate. You are teaching them to establish new relationships and ways of producing new knowledge. So, but anyway, this is the end of my first part. I tried to give you a very, very, very brief synthesis of what happened in the replication crisis and how psychology is going about this. Of course, this is a very long-term process. It started only about 10 years ago. So you're not going to change the practices of a whole community with literally 100 years on the run from one decade to another. It has to take time, but you need to make these discussions, and it has to appear in the journals, and it has to be discussed thoroughly. So I'm going to focus now in the approaches to replication-based learning. As I said, in psychology, there's been different ways of trying to make students learn how to make open science and how to make replication part of their profile of their identity. So these are just 3 better practices that I think that are relevant for us. One is trying to embed open and reproducible science into teaching, and not only into teaching at the individual level, also in our curricula, for example, in our master's courses, right? And in psychology, if in some master's programs, there's now a module on replication, or how to replicate, how to select something that is worth replicating and how to do it. Of course, together with the module of how to conduct open science, how to produce a protocol, how to send it, how to report transparently, right? The other good practice that I think is relevant for us is doing replication studies for master's and PhD thesis. As Mario said, we had one experience on that so far, and later on I will tell you more of how we actually did that. But we need to do that more. That's the thing. And of course, this makes you think not only from the perspective of the thesis supervisor, but also as the perspective from the perspective of the thesis of the one who is going to review, who examine that thesis, right? I think that nowadays, if I make one of my students, if I have two students, and one of them is going to make one original study, and the other one is going to make a replication, the one with the replication is going to have it more difficult to convince I forgot the word, to convince the examiners that this work, that it's actually valuable work, is actually equally valuable than an original work. And I think that's something, it's very cultural. It's something that it's in our way of thinking about how we produce knowledge. And that's a very, very big challenge. Because how can you convince someone that a replication is equally valuable as an original study? It is very difficult, and yet it is, right? So we need to work on that. Another good practice is making the students participate in the production of high quality direct replications. That is constructing a practice. That's constructing the ways of doing, okay, now replication is part of my set of skills as a student, as a researcher, right? So these are good practices that they do. One example is this one. There is this project which is called the Collaborative Replications and Education Project, which works in, is a complicated process, but the idea is very simple. You have a number of different laboratories of research groups and invite their students to participate in a number of different replication studies. And then you coordinate, right? You try to coordinate the groups and the students to say, okay, we're going to go through the same process. So send me your proposal, send me your protocol, tell me which study you want to participate, and then we all together go through, right? But as you can see here, the word and the practice of collaboration is a very important part of this. If we think about replication as the effort of some individual in one specific research group, is not going to work. We need to think about replication as a collaborative effort across different universities, different research groups, for it to really work. Of course, when you want to make your study transparent, you are encouraging that collaboration, right? And if you don't have that set of mind, it's going to be very difficult for our community to adopt collaboration as a practice, as part of the everyday practice. So this is one example, and with this kind of project, they produce, for example, this paper, which is another. I selected my examples because I thought they were going to be like controversial claims, right? And this one is the controversial claim that when women see the picture of a man with a red square around it, with a red mark, the man is going to be perceived as much more attractive than if the same picture is seen with a gray mark, right? Okay? So this is actually being published, and it was published in a very good journal with at least 3 different experiments on the same hypothesis, right? But then, with this replication project for students, it turns out that across, I think there were about 20 different replications, no, 8 student projects that replicated this result of the attractiveness of men in a red background. The replication showed no effect at all. So that effect It's not that it doesn't exist. Again, if the replication doesn't show the same result, it's not proving that the finding is false. It's just that there are certain conditions that are making this not reproducible, and we need to think about which conditions are those, right? Okay, because that's, I think, and this is not something, this is only coming from my mind. I think that one of the things that make people resistant to engage in replication processes is some sort of fear that what if they don't replicate my study? They are going to think that I invented my result, or I did something wrong, okay? But the idea of replicating is not that. It's just finding ways in trying to find explanations for why is this not replicating. Of course, it can be that you made a mistake, of course, a mistake of measurement, or it was not an appropriate method for proving what you thought. It can be anything, but it doesn't make your finding false. You just need to think about it more, right? Okay, so this is one example of good practice of how to engage a student in the practice of replicating, with, of course, with the incentive of that at the end of the process you're going to have your paper published, right? That means you're going to get recognition for that, okay? Instead of being rejected at the beginning, or in being encouraged to forget about replicating something and do something original instead. So now I want to talk to you about our own experiences. That's what I think is going to make you interested about this. So first of all, this is I'm going to talk about. I'm going to talk to you about two different attempts to introduce replication to graduate students in mathematics education programs. One is the one that Mario told us about, and the other one is the one I made with my colleague Ana Medrano at CINVESTAV. Both of them are for master thesis. One ended up as a master thesis and a published paper, and the other one is still going on, so it's work in progress. Okay. So the first one is this master thesis that we made with our student Javier Hernandez, and we replicated this study by John Van Hoof called "Are Secondary School Students Still Hampered by the Natural Number Bias? A Reaction Time Study on Fraction Comparison Tasks." So, of course, one thing, our experiences in specifically this experience of replication was somehow, well, not somehow, was closer to the way of doing research in experimental psychology. So it may not be like very representative of the kind of research that we do in mathematics education, where the dominant paradigm, of course, is qualitative research. But of course, it's a helpful start, I think. And it was published on Research in Mathematics Education. So that was one reason for selecting it to be replicated. And the other reasons were, for example, that this finding of the natural number bias, which is when people attribute properties of natural numbers to fractions, it's very well known. I mean, it's been found under different samples of different ages, from young students in primary school to expert mathematicians. I mean, we all have it, right? And this is a sort of result that has been replicated so many times under many different conditions that I can actually say that it is an actual phenomenon. I mean, it's real, okay? So that's why I suggested to Mario, okay, we can work on this, right? We can work on this, and it should be useful because I thought we will have to find it. I mean, if we don't find the natural number bias in our Mexican sample, then we can learn that we did something wrong, right? because it's so widespread. So the other thing is that it's so well known that it's been theorized a lot. So the theory fits very well with the hypothesis that what is stated in this paper, and then makes our work much easier because we know whether we found the result, whether we replicate it or not, depending on whether the predictions made in this paper match with our findings, right? So there was clarity. Technically, it was not difficult to do because here Joe made it with a computer program, and that sort of computer program is very easy to find. And Javier was a computer engineer. So we tried to find something that was feasible for our student. I'm going to give you more details in a second. This is the one that ended up in a master's thesis. And of course, in this article published in our journal, right? So the one that I'm currently working on is this other, is trying to make master's student to work throughout a year in the replication of this paper, which is called Substitution and Sameness, Two Components of a Relational Conception of the Equal Sign, which is made by the Mathematical Cognition Group in Loughborough University. And again, this paper is in itself a replication, right? Because the original paper tried to find what are the interpretations of the equal signs that primary and secondary students have. The idea here is trying to emphasize how the teaching of arithmetic in primary school focuses on making an interpretation of the equal signs, of the equal sign as an operative symbol, meaning that students see the equal sign and what they think is, oh, I need to make an operation. After the equal sign comes the result of an operation, right? That's called the operational meaning of the equal sign. Again, it's very well known. It's been found throughout different samples throughout the years. And if you go to primary school and apply the same questionnaire that it's been reported here, that has been used under different samples, you will find it. Again, that's a finding that it's very reliable, okay? And in this particular paper, what the authors made was a comparison between English students and Chinese students, with the hypothesis that Chinese students will not only have the operational meaning of the equal sign, but also the relational meaning of the equal sign, which is, and when you see that the equal sign is not just an operation, it's a way of relating the two parts of an equation, right? And one example of that was that when you can substitute this part with the other one, right? You can move it, which is very relevant in algebra, of course, okay? The idea in this paper was that they already knew that English students would have an emphasis on the operational interpretation of the equal sign. But they, after reviewing textbooks and curricula in China, thought, okay, Chinese students should also have the relational understanding of the equal sign. So this paper is about that, and that's what they found, okay? So then I thought, okay, and I thought, okay, we wanted the students to get introduced to research methods, to quantitative research methods in our master's program. And we thought, okay, how can we do that? Previously, we had, of course, made students from previous generations to produce an original project. So, okay, just think something you want to do, a small experiment, and run it, okay? And students, it was very difficult because almost every student wanted to do something of their own, right? And it was very complicated to coordinate, for example, how to produce materials. or how to run it, what were going to be the parameters for doing the analysis and so on. But then this year we thought, okay, let's do something different. And because I had the previous experience with Mario, I told my colleague, okay, let's try a replication. That has to work, because in one way it has lots of pedagogical value, because it's again, it's very simple materials. The analysis is feasible, is something that they are learning in the other module of statistical analysis, so it complements very well, right? And again, the hypothesis is very clear. The theorization of this paper, it's very abundant. So we can make students think about the theory in a very direct way for interpreting the results. The idea being that if they find something different to the original paper, they can manage the theory to make an interpretation of why they didn't replicate, right? Okay. So when we think about this kind of projects, I think that it's very important to think about a number of things. For example, what's the selection criteria for saying, okay, I want my students to replicate this particular study. One can be, for example, that as I've been telling you, having a clear theoretical background and hypothesis. This is the what I was telling you. In the Van Hoof paper about the natural number bias, they made, for example, I think 4 predictions, but this is one of them. It is very clear. I mean, the theory, the way in which Joe phrased this prediction was like this. She said, we predicted that incongruent items would trigger more mistakes because the incorrectly intuitive answer was not inhibited through the analytical reasoning system than congruent items. By congruent and incongruent, they mean that the experiment was about presenting. The experiment was a fraction comparison task where students had to see which of 2 fractions was bigger, right? And the one that is called congruent is when the students thought that the bigger fraction was the one with the biggest natural number, right? And incongruent when they thought that the biggest fraction was actually the biggest fraction regardless of whether it had the bigger natural number or not, okay? So this is what she meant with this is what she meant with incongruent and congruent. And again, then she said, secondly, we predicted that because inhibited and intuitive answer requires time, there would be longer reaction times on correctly solved incongruent items than on currently solved congruent items. So this is prediction 1A and prediction 1B. After reviewing the paper and discussing it with our students, we, of course, made them go and get the data. So he had to find ways of getting the participants. At that time, we were still, I think, on pandemic times. I think so. We were just started to, at the time, the schools were just restarting, okay? And there were many differences between the ways in which Jo made her study and the way we did it. One was that she did the study individually, that she asked every student to come to a small room and run the computerized experiment. Whereas for Javier, because of the conditions of the schools, he had to do it in groups, right? And for some subset of the sample, he had to do it remotely, right? So those are different conditions that were part of the context of this replication that made, even when we tried to match everything that we could from the original experiment, those were conditions that we couldn't control, right? So when we had to take that into account in the interpretation of our results. So I think Mario showed you a table where we had on one column the methodological characteristics of the original paper and the ones that we did, right? Here I have this table where we compare whether our study replicated, supported the predictions made in the original study. And for example, here for these two, we found that the original study did not support the first prediction, but we did. The second study, second prediction, both studies supported that prediction. I want to emphasize this bit because here the original authors predicted something based on theory and they didn't find it, right? And they said, okay, we didn't find, our hypothesis was not supported by the data. But we, in our replication, we did found what they were looking for saying like that. See? That was interesting. And that was the main difference between our replication and the original study, right? So we thought it was interesting because the aim of this paper was to prove that older students are still sensitive to the natural number bias. And the evidence of that was not as complete, whereas our replication had a more complete evidence of that, right? So in our sample, the natural number bias was stronger than in the original paper, right? And for our student, it was, I'm not going to say easy to see, but it was something that it was within his reach of understanding as a scientist, as a researcher information, right? I remember we had discussions with Javier about trying to make him figure out why. Why do you think in your sample the natural number bias is stronger than in the Belgium sample, right? And I think that, and this is just one hypothesis, a belief, not a hypothesis, a belief I have, that for him it was much easier to make a deeper interpretation of his results because he had the reference of the original study, because he had this reference of this comparison, because he came out with interpretations like, okay, I would like to see, I will need to see what's the curriculum in them there. One thing. The other one is, as reported here in the original study, I don't know if it's reported, but anyway, one important factor was that the sample of our replication was very heterogeneous. There were, although there were students of the same age, they were attending different school formats. I remember one subset of the sample attended a public school, whereas the other one attended a private school. And that difference is very common here in Mexico and creates lots of different factors that make students not make different conditions for learning, right? And that's something that made our students reflect about the importance of those conditions for this particular effect that I think he could not, it was going to be more difficult for him to achieve this depth in interpretation without the reference of the original study, right? So that's something I think it was important. And that's why it's important to select articles where there's clarity on what they are supposed to say and on the claims that they make. Another important selection criteria is transparency of methods and materials. This is from the equals sign paper. This is the set of items that they used in his research and what's the predicted conception of each item. In this paradigm that they used is a conceptual understanding paradigm where you ask the student to make a judgment about someone else's way of thinking, right? For example, here the question for the students in the questionnaire was, I don't know, Jose thinks that the equal signs means the answer to the problem, right? And the participant has to use a scale to rate how, to the extent to his agreement with the opinion of this fictional person, right? So, as I said, this sort of material, this questionnaire, is easy to translate, is easy to produce, is adequate for master's students to have a look into, okay, I'm going to make an instrument, right? Which instrument? This one. All right. And why this instrument? Because each of these questions has, right, a background, which is with a strong theoretical foundation, right? From the perspective from the theoretical perspective of this student, the equal signs carries concepts. And these are the different conceptions of the equal signs, right? Operational, sameness, and substitutive. The idea is that by engaging in this replication, our master's students will get to understand what are the theoretical bases of this way of understanding how young primary school students and secondary students learn about the equal sign, right? But the emphasis is on very practical things like the instrument, right? Other criteria that I think is important is, of course, that students are interested about that. And again, this has to do with the way in which we select our studies. I mean, we need to think, why can this be interesting for my student, right? It would, I think, in every community, in our community for sure, some papers are like the target public is not students, right? They're the different papers that are for different people at different stages of their career. There are some other papers that are more accessible for students, right? And I think we can start with them. The other one is the impact of what we want to replicate. I mean, how relevant is this finding that they want to replicate? The other one is the feasibility. And this, sorry, I'm going back to impact. Impact is important, especially in our discipline, because it's a very practical discipline. Our papers are actually, many of them are actually practical papers. Are, for example, teaching experiments. I mean, the gap between research and practice sometimes is very blurred, right? Sometimes teacher is researcher, teaching is researching, right? And that's something that is a challenge for us to think about when we think about how do you replicate that sort of thing, right? Our research is not laboratory research. It's research in the context. And how do you replicate that? Right. Now, I ask our students these 4 questions to see what's to learn about their experiences with the replication projects, right? It's a very small survey. I actually took the questions from another survey, from a study on replications with graduate students in sociology, right? But the questions are the same. Here, I think they apply equally well. First question, what did you learn from the replication process? And this is in Spanish. I want to make my own translation of this. One student said, the process of researching, the management of times, and the importance of ethical documents. Another student said that the results are very similar even when the sample is completely different, right? So one important thing that I want to emphasize here is this ethical part, right? The ethical part in research sometimes is, I mean, it requires more work in our community. At the moment, the ethical part on our research is just not like formally institutionalized, right? Not all of our journals make this requirement in the same way as it's in different disciplines, in other disciplines like psychology. And I think replicating pushes you to think about it, okay? This other part where the student realizes that the results are very similar even when the sample is completely different is exactly what we want to achieve with replication for students. So they think, okay, this result holds, even if Mexico is very different to England and China. Right. Second question. What advice would you give to future students starting a replication process? So the first student said, studying very well the documents to replicate, understand the objectives and the objectives that have been set. And also follow very closely the process, the coding and the analysis. And also think and work with schools where you're planning to apply your instruments of replications, as well as taking into account the times and the moments that you have to use for that. Sorry about my translation. But anyway, the idea here is that the student is realizing the importance of the very practical things of going to do research, right? So I'm doing my replications, I know what to do, but then how can I go about it in practical terms? I need to call the school, I need to go visit the teacher, I need to convince the teacher to participate, and I need to do all that before I can go and collect my data. And this part sometimes, of course, it's never reported, right, in a paper. When the students read the paper, that they don't realize all the work that is behind that. All the administrative work of going to convince a school to participate in your project is very difficult. And I think replication projects make that a bit easier, because if you go to a school and tell them, look, director or teacher, I'm going to do this in your school, I know it works, right? I know it works because it's been published. Just let me do it again here with your students, with your groups. Okay. The other student said here, make the process with honesty and objectivity as possible. So again, the ethical part of it and the adoption of an identity as a researcher that has to that behave ethically is also a very important learning outcome here. Number 3, has the replication processes been helpful in your studies? One student said, very useful. Is my first approach to research, and being able to follow step by step what's been done before by someone else lets you experiment very vividly the work of a researcher following a very approved, very well-defined and proved base, right? The other student said, it's useful because it was my first approach to one very important part of our research, which is data collection, which is something that I'm going to do for my project, for my thesis project. So here again, that's another way of working with replication in graduate school. It doesn't have to be your thesis, but it can be a training before you go and make your thesis, right? That's another way. Number 4, how would you improve the replication process? One student said, in a personal way, I would like to have had more precision in theory, more explicitly in the elaboration of the instrument, and not just keep the translation. And a feedback that is closer to get to visualize that the results are equal, similar, or different, if that's the case, to the ones obtained by the original authors. This one is very important. I wanted to emphasize, I like this one because it's some homework I have to do, which is go with the students more closely, right? At the time, I asked the students to go and do the replication, and as I can see here, I need to be closer to them. I need to give them more feedback on how they went about it. So that's one thing to learn for me. Another student said that things can improve with schools that are willing to collaborate in the application of such studies, because it's very complex that schools let you work, or that they have the willing to collaborate. Here, I like this answer because it emphasizes the part of collaboration that I was telling you about. Replication and collaboration are just linked together so closely and students need to learn need to learn about that as well. Right. Part 4. I'm nearly there. Sketching replication-based learning in mathematics education. Let's start with the benefits, right? What I want to present here is just like the point that we need to start to discuss that in a more systematic and abundant way. We need to engage in more events like this one where we can discuss, okay, what do we do with this part? If we want replications to be part of our culture, we need to think about our students as well. But how do we do that? So let's start, just to motivate you a bit, although of course if you are here, I think you are already motivated, but if we go to some other conference, I would like to present these points as well. One is that if you engage your students in replication-based learning, you can obtain lots of very different benefits. And that's important because postgraduate studies can be transformative experiences. And during your doctoral studies or your master's studies, you are not only learning about research, you are becoming a researcher. You are adopting cultural norms. You are adopting an identity, a way of seeing yourself. And you need to see yourself with this. You need to learn to design and execute empirical research. With a replication, you can analyze and interpret replication results. You can gain deeper theoretical insights through constructive replications, like in the case of Javier that I was telling you a minute ago. You can also discover how replications improve scientific progress, and that's important for changing your attitude and changing the belief that replications have less value than original studies. And one very important, which is learning to collaborate. But of course, we need to think about how to do that, how to get to these benefits. Just 3 very simple points. One is we need to think about how to theorize about replication-based learning in maths education. Something that I believe is a very, very important and unique characteristic of our discipline that makes it different to psychology, for example, is the importance that we give to theorization. Theorizing is very important in maths education. And theorizing has to be applied here as well. We need to theorize, what sort of theoretical framework we need to use to start thinking about replication-based learning. I think, and that's just my opinion, that we can we can begin with the idea of communities of practice by Leib and Wenger. I think that would be adequate if we see ourselves as a community of practice and our students are apprentices. We can start to think ways of introducing this in our curriculum. Now, the other thing we need to think about is what do we want to achieve with replication-based learning in maths education? What are the objectives? What we want to achieve with that? One thing is trying to nourish a scientific identity in our students. We need to see themselves as scientists. The other thing, which is important, is what to replicate. What is worth replicating, and how can we replicate it? I don't know if I have time for this. I wanted to make an activity, or I make a shift very quickly. Can I have one volunteer? Please? No? Okay. Okay, Francisco. Thank you. You, Francisco. Well, Francisco is a student, so it's a bit unfair. I will ask one colleague who have already had experience with graduate students, please. Boris. Well, let's hear Francisco and then you. Is that okay? Good. Okay, Francisco. Think of a study whose replication might be helpful for graduate students. And please answer these questions. What is the key result that is worth replicating? What's the pedagogical value of the study? How would you go about it? How would you do it?
My first idea maybe comes from some of the experiments of Kahneman and Tversky from psychology
Okay.
that talks about probability, maybe.
All right. Okay.
Because they are like very easy to replicate.
Okay.
Like taking samples from persons, and it's easy to find biases, like psychology biases about probability. So the key results that it's worth replicating is like finding like how people have biases in thinking, maybe about probability, or these characteristics of sampling representation, or like thinking that some of the results are like more probable when they are not, maybe. And how, I mean, I think that these are like very easy to replicate experiments, no?
Okay. It's feasible.
And yes,
Okay.
and the pedagogical value of this study, I think, is a lot like maybe understanding all the theory of Kahneman, that it's very interesting in not only in math but in social science in general and economy.
Mhm.
And how would you go about it? I don't understand this. Like,
Oh, how would you do it in practical terms? Would you do
okay.
it as a thesis, as a part of a module, as a workshop?
Maybe like
how would you do it?
okay. Yes, maybe like something like you can do even like a very quick query with like for example a forum, or even your colleagues, or I mean those biases are like something that every human has, no? Because like when throwing, for example, 4 dice, or like the questions are like I don't know if you are familiarized with Kahneman research and Tversky, but the questions are like about throwing 6 dice and thinking what is more probable, like having 6 different results, or like having 3 and 3, for example. So it's very easy to see the biases on how people think. So that's my first reflection about it.
Oh, that's great. That's a very good idea. Okay. I'm sorry. I think it's Boris's time. Microphone. Yeah. Sorry.
Thank you very much.
Yes.
A study in my mind, and actually I didn't invent it right now. We do it for some time in my department in a master course for practicing teacher. Is a study by Fishbane and Kedem, 1979. The result is that based on a very clever questionnaire with more than 100 students, school students, they found that even after appreciating a formal proof to a general mathematical statements, students need examples to be more convinced. This study has been replicated in several ways. In the original study, there are no obvious pedagogical implications. They just reported. And in the course, we tried this. This is the third question. How would you go about it? We had a group of about 20 teachers who studied deeply this paper. And then we asked them to invent a protocol of an interview with an individual student that would explore from different angles if this phenomenon exists in this particular student. It was interesting. They used something from the initial questionnaire, but added a lot of pedagogical stuff. And based on this data, we were able to say something about we told it it's not classic replication, it's not conceptual replication, it's direct replication. We call it just teacher replication, that it has its own specificity. And then we try to characterize learning opportunities for teachers in doing this exercise inspired by an idea of replication.
Right. Yeah, that's actually very exciting. This idea of teacher replication, and I think that can be something unique of our discipline. It's like something that the sort of thing that I would like to emphasize is that we need to create our own way of inducing students into this ethos of replication. And I think that was great one. That's a great one, Boris. Thank you. There was someone else over there. Yep.
Ay, perdón, ¿lo puedo decir en español?
Sí puedes, sí.
Perdón. No, nada más quería agregar con respecto a lo que dijeron ahorita de los estudios de Kahneman, de los sesgos o ideas erróneas sobre probabilidad condicional, que me parece que también son muy sencillos de cierta forma como de replicar y encontrar. En el caso de, por ejemplo, en el caso de los resultados, creo que lo comentaba el día de ayer que yo estoy trabajando con un cuestionario de días sobre ideas erróneas sobre probabilidad condicional. Entonces, en el caso del valor de la replicación, por ejemplo, en mi caso es que yo trabajo con estudiantes de ingeniería. Entonces, dentro del currículum viene los conceptos de probabilidad condicional. Y dentro de eso, por ejemplo, la parte del valor pedagógico es explorar estas ideas erróneas que tienen los estudiantes y también es muy importante para la toma de decisiones. En el caso de ingeniería, por ejemplo, podría ser un ejemplo muy sencillo de máquinas de producción, los errores que se cometen a lo mejor en ciertas piezas, de dónde viene, aplicando también un poquito del teorema de Bayes en ese caso. Y con esa toma de decisiones, porque son incluso con preparación, los alumnos o con instrucción tienen complicaciones para atender esas ideas erróneas, que tienen muchas implicaciones en estadística inferencial, incluso en pruebas de hipótesis, por ejemplo. Entonces, pues ahí viene la parte de la importancia de también hacer estos estudios de replicación y entender dónde se confunden los alumnos, dónde tienen estas ideas erróneas, incluso poder trabajarlas pues con ellos, ¿no? Y con los profesores que les dan clases, porque también hay ideas erróneas en los profes, una proporción incluso hasta similar.
Okay, well, I'm sorry, I'm not going to make the whole translation, but ¿cómo te llamas? But Alan's idea was that it can be very useful to replicate the Kahneman studies with his students, because he teaches to engineering studies, right? Students, and he's seeing some pedagogical value about learning how engineering students still have those biases. And I think the idea of replicating some of these Kahneman experiments about conditional probability can let you see more clearly how is this happening in that context. That's my interpretation and translation. Sorry. Okay, my last one, promise. Take-home messages. One is adopting replication-based learning implies rethinking our formative practices. So we as supervisors and curriculum designers, we need to think, okay, we need to rethink what we want to achieve with what's the profile, what's the identity of the student that I want to nourish. Second, we need to discuss how to theorize replication-based learning. I already mentioned that. And third one, important for us in a way that is not important in other fields, is that there is a need to use our pedagogical lenses to embed replications in our curriculum. That's it. Thank you.
Ulises, this was great. I got ideas, I got references I want to read, I got stimulated. Thank you very much, Ulises. We have time for a couple of questions, comments. Carlos, you want? Yes, okay.
Hello, thank you for the presentation. You mentioned in the second part about something about fear. So I think you were in that phase at certain moment. How have you dealt with that fear?
Oh, you mean the fear of
sharing
of your study being
yeah,
replicated? and
exactly.
That the group finds something different. That
Or maybe you
what
were
you found?
wrong, I think you said.
Yeah, I think that stems from. I was talking about this presentation yesterday with my wife. She's also a researcher in neuroscience, and she said, okay, because we've been taught when we were students that original studies were more valuable than replication studies. We also, of course, felt that part of that is the belief that if your experiment or your study, your findings are not replicated, then there's something wrong with your study. And as I said, it's not like that. You need to think, why is this different? What happened? It's just a different way of finding new knowledge. But again, it's something formative. I mean, my wife and I went to university ages ago, so we were formed in that way, right? Our teachers and the researchers that taught us how to make research infuse those beliefs in us. And when we need to make the work of just sort of kind of like a therapeutic work of removing that belief and change your beliefs and change your attitude, and again, that will lead you to change your attitude. That's how you need to recognize first that that's the fear, right? Okay, yeah, I wouldn't like to. I don't want someone to replicate my experiment and find something different, because then I'm wrong. But that's not the case. You are not wrong. You just found new knowledge.
Okay, thank you.
Thank you for your presentation. Very interesting, I think. Don't you think it's also a fear practiced by editors and reviewers at journals? I mean, that they simply don't want to accept replication studies, or at least it was so for a while, because they think that it is not original.
Yeah, of course, that's an institutional, a structural part of a structural origin of that belief or that value of the evaluation of replication studies. Of course, it's there. That's why I wanted to give you these examples of the precognition example, because of course, this is just a finding that you say, okay, people can feel something about the future, and it's been done in a scientific way. Of course, I want this in my journal. This is the kind of thing that is going to make people read my journal, right? Whereas at that time, if you submitted something, some replication of other study, and they found this one, of course they're going to select this one, because it's all structural, right? He's trying to, I think the journals will try to find, or at least at that time, we're trying to see what the most interesting findings, the findings that make people read that journal. I think that's the interest, instead of a scientific interest of trying to publish actual construction of knowledge. I think that's the case. But that, again, this is part of a process that it's still going on. It's a very long-term process. It's changing beliefs that have been here with us for ages. So, yeah, I think so. I don't know if I answered your question. Okay.
Yo quisiera saber si requerimos la autorización del autor para replicar su estudio, si sería posible que no quisiera compartirnos los instrumentos que utilizó. Y una última, si al encontrar nosotros...
Déjame traducir la primera. Lulu is a student with us. She's asking a very good question. She is asking whether we need to ask the original author for permission to replicate his or her study, and whether we need to ask him or her to share or to use his or her materials, right? That's the first question. Segundo.
Si no quisiera compartirnos, o si hay la posibilidad de que no comparta sus instrumentos, lo que utilizó para su investigación.
Second question, much more interesting. If it's possible at all that the original author wouldn't want to share his materials or instruments for conducting a replication. I think you don't need to ask permission to the researcher to make a replication, because once it's been published, it's part of the scientific community. So everyone can. That's the idea of publishing a paper, that someone else can just not just read it, that can replicate it. That's the whole idea. You don't need to ask permission. That's in the first place. But in the second part of your question, whether some researcher wouldn't like to share his or materials or instruments, I don't know if that actually happens. To the extent of my knowledge, that doesn't happen. Or in my experience, when you ask for something to another colleague, they will give it straight away to you.
La tercera, sí, sería posible que nos solicitara o deberíamos compartirle nuestros resultados de su estudio
Oh,
original.
good. The third question is whether if we would need to share the replication results with the original author. I think that's a very good practice. You can do it in different ways. You can arrange a meeting, or you can just publish it. That's another way of collaborating. But in our experiences, it's better to have a conversation. We had a conversation with Jo Van Hoof, Mario and I, the other day, and we told her we replicated this, and she was really interested. I think as a researcher, it's kind of like a recognition of the importance of your work, that someone wants to replicate it, right? So yeah, and that's also a way of encouraging collaboration. So yes, you must, yes. Okay.
Thanks. It was very interesting. I have one question and one reflection. The question is like, how, when you replicate one study, you do the literature review? If, I mean, I think it's like almost the same as the original study. That's the question. And my reflection is like, I will try to explain it, but when you find a significant result, and you say that it's significant because something weird or with a very low probability happened. So this is a conditional probability. Significance is claimed when it's given that the null hypothesis is true, then something very weird happened. And in general, when this happened, when we found a significant result, we say that so the null hypothesis must be false. No, it's actually a bias. But as a metaphor, when we throw like two dice, and if we throw two dice, and as the first time we throw it, we found like we have 2 6, it's also a significant result. And we create theories about why those dice are biases. And a lot of, maybe we can publish a journal about, like why those dice are biased. But maybe it was just probable, something that has a very low probability, but happened at the first time. So in that sense, I think like replication is needed, because not only I mean, it's needed to find again that it was not something like very low probably happened, but that dice were biased, like and it is needed in the same conditions as the first exam. So it was just a reflection that I have about from your conference.
No, it's a very important reflection. At some point, I mentioned that there are cognitive biases that let us believe that when some experiments being published and present significant results, then it's actually proving that the hypothesis is true. But of course, that's not the case in probability terms, of course. So yeah, it's part of the things that we need to make our students aware of. Yeah. Okay.
Thank you, Ulises. I speak English. Do you think it's necessary everyone research thinking about condition and possibility for the replicate? I understand it's necessary step by step in the methodology, but what more?
Well, I think if we want to make this a meaningful experience for students, we need to start even with the literature review, as Francisco said. It doesn't have to be the exact same literature review that the original study, because one way of making a replication is saying, okay, I'm going to present the same study, I'm going to use the same methods, but seen in a different way, okay, with a different theoretical framework, for example. But we need to give you students a closer following up of those processes, because those are the processes of being a researcher. You need to start from a position of critical thinking about what you're reading. And then I think it's not just about the methods. Methods are important, but it's also the way of thinking about the finding about the study.
So also it's possible to consider another subject.
For example,
Yeah, it is possible. For example, I mean, when I study about the representation of the whole numbers, and then do another study with the fractions.
yes, I think you can think about the sort of investigation that you want to make and make a replication part of it, right? So, okay, I want to replicate this, but then I want to make this extension where I'm going to change this bit of the methodology to see whether the result holds, and see, or not just to see, you need to find a reason to do that. That's important. It's just, why would you do that? Why would you do it differently? What do you want to know? That's the sort of thinking behind it.
Thank you.
What do you think? Can you share your
Sure.
slides for
Yeah, yeah.
replicating them?
You can
Okay.
replicate everything. Of
Okay.
course.
Yes.
I don't
will-
know how, but yes. of
Yeah,
course.
if
I'll
you
make
give
a
it to me, and I will upload
Sure.
it as I did with Ula's slides.
Yes.
Thank you, Ulises. This was
Oh,
great,
thank
as
you,
I
thank
said.
you.
I think it was a good choice to bring Ulises. Now we are having a break, okay? And after that, a workshop. I'm looking forward for the workshop too. Thank you, guys.